In today's video, I want to look at rectangular beams and maybe in particular continuous rectangular beam as the model shows in front. Also, I do want to do it manually using rebar sets to show a workflow that you can accomplish a very quick solution with rebar sets manually and pretty much tailor the outcome of the design to what the engineers want precisely. There are, however, heaps of component solutions regarding beams, some with strand patterns, some with spandrels, strip beams, and so forth. There's a lot here. So, like a ledger beam, also spandrel beam. So there's a lot of other options here. They are a bit of what I regard as legacy components. So they pertain to single and group bars. There's very few of them that actually have, or none that have rebar sets in them. There's also the continuous beam component, which works very well, but sometimes I find it takes longer to set the dialog boxes inside the component to tweak it to your desired design rather than just manually modeling it up from scratch. Gives you a bit more control. So with that in mind, also I do want to follow some sort of a guide. I don't have much in terms of a design in front of me, but what I do have is a little extract from the reinforcement detailing handbook, and it's available from the Concrete Institute of Australia. It's an extremely comprehensive manual regarding the reinforcement of all components and the rules and regulations around them. But what I do want to do is just follow this guideline in terms of the layout of the beam in elevation. We have bottom and top bars. We do have a connection around the column where the splice on the bottom is slightly shorter than the splice on the top. And from what I understand is your negative bending moment that sort of flows over here. It's where it crosses the zero line. That's really where you want to get the splice, and it's a bit further away from the column. It doesn't. There's no positive moment. The positive moment is in the middle of the beam. So that's where the heavy lifting will be, and pretty much the same on the end, because if this column is regarded as fixity with the beam, you'll have another negative moment up in this column, and therefore the splice is a bit further out. So we'll sort of follow this guideline very roughly in terms of the reinforcement. And then in terms of the, exactly what it looks like over the column, you can clearly see, they carry these bars in a bit further than the bottom bars. And we'll do a bit of extras, we have and I'll just move this out of the way. If we look at our model, we've got short spans on the ends and we've got a long span in the middle, and we'll just pretend the engineer wants some extra reinforcement in the middle of this beam. So with that in mind, I think let's start. I've got two views open. If we go to, and I'll just go back to my property pane. If we go to the window, I've got two views. I've got an elevation on the beam, and then also I've got the 3D model. So we'll just use that. So first of all, I'll go to transparent mode, and I've taken the liberty just to push some column reinforcement in there. So we just got context in this regard. And then what I'll also do is so we can see the beam in isolation, I'll go over to my selection view selection sets, and I'll go to cast in place beam. So we'll only see the beams in this regard. Okay, so the first thing we're going to do is we're going to start from the outer layer. So I'll do the ligatures first, and remember we'll be doing this manually with rebar sets. So crossing bars is the option here, and then for the ligatures, we will use an end grade. It's normal in beams. We don't necessarily use R steel in beams. We do use them in columns, however, but in beams, it's very seldom that you ever use R steel as a ligature, and it's normally an R12 tie as a minimum. So we'll select that, and then for our color, we'll stick to the traditional 5, which is ligatures. And then for our spacing, we'll just go for a 300 spacing, and we'll just stick with that for the minute. And then what I'll do is I'll just quickly populate that beam. I'll also do the middle beam, and I will do the end beam. And while we're there, we might as well just quickly put an end modifier. And I think the norm with the end modifier, if I just pick the end modifier, is to have a 135-degree hook here, which we can use, but I think I mean, you can set that anytime you want, but I think for the clarity of this video, just to see the other bars, I'm going to stick with the 90-degree so the hook doesn't get in the way for visual effect, but we can change it at any time. And what I like to do is I always like to just call up my default just to make sure that my palette is reset to where I want. And once I have that, I can just hover over the edge of where the joint is and it populates that one. And we can do the same in the middle one. Click on the bar, end modifier, hover over the edge of the beam, populate that one. And then lastly, we'll do this one, end modifier, hover over that, and that's done. Okay, now what we can do is, now that we've got the linkages in place, we can flick over to our element, our elevation. Again here, what I'll do is go transparent. And then what I will do is I'll start with this first one. Now, if we just pull our picture back in view again, over these spliced areas, the spacing of the linkages are normally a half of the spacing of the main, or it can be specified specifically by the engineer. In some cases, it can even be double linkages. So it doesn't matter. The spacing is dealt with the same. So what we're going to do to start out with is the engineer is calling for 24 bars, so it will be 1,000 lap as a standard lap. So we'll deal with I think 5 spacings at 150 for the end. So to start out with, we need to push this bar a little bit away from the column to give the guys working room. So let's just start with half of the short space, which is 75, which is a good start. Another 75, and then for the target value, and let's just accept that just to see what happens. So it's pushed the reinforcement a little bit away from the columns. Now for the spacing, I will flick over to exact spacing. We've got 11 bars. So what I'll do is I'll just clear that for now. And then what I'll say is I'll start with 5 times 150 for our one edge and 5 times 150 for the other side. And in the middle of those two, I'm just going to take a guess and say 5 times 300 in the center. And once I've got that, I'm just going to hit the bar and say, okay, now, if we look at that, we can see we've got an imbalance there. That cover there is smaller than this color. And a good way to sort of set all of that or get that perfectly is to click on the modifier and then go to modify spacings. And then Tekla will show you've got 75 cover there, you've got 5 at 150, 5 at 300, and then yeah, it clearly says a red, which means I couldn't fit enough in. So, and you can see there's only 4 bars there. So what we can do is we can flick over here and say, okay, the 5 is too much. Let's go 4 and say enter. Now we can see because we've got black, all the bars have been pushed in. But if we zoom up here, we've got 50 millimeter grace. Now 50 millimeters, what we can do with that is we can half it. So it's 25 and we can just add it to the 75. So you know, if we go now and say add 25 to that 75, it's 100 on that side as a working distance. Controller and 100 on that side as a working distance. And that's sort of, if you now look at the values, we've got 100 that side, we've got 5 at 150, we've got 4 at 300, we've got 5 at 150, and then on the edge we've got 100 again. So that's perfectly spaced beam. Now, since we've got that already selected, we might as well just go over to our painter and copy the properties, and then scroll over to the other side, click on this set, and say modify to apply the same settings to that. And just like that, we've sorted out precise settings for our 2 edge beams what linkages are concerned, and it will also look nice when we do the drawings. So for the middle part, we'll have the same approach. So in here, we can say we start with our 75 again, control all 75. And then for our target spacing, leave it at 300 and say modify 22 bars. So now what we can do is, again, we can go over to exact spacings. I'll select all of this and say we 5 at 150, 5 at 150. That's for the 2 edges, and then just go in between them and say, let's just start with, say, for instance, 10 at 300. I'm just guessing a value here. And if I say enter, we can see we're well short. Again, we can just click on this value and say bring up the value. So we can see we're well short here. So I guess 10, 15. Let's make that 15 at 300. So that brings us a lot closer. And now if we zoom up here and we look at what's the shortfall, there's 250 millimeters here. Now if I divide that in two, I get 125. It's not really suited for an end distance, and it's also not suited for a middle distance. So what do we do here? So the quick way to get around here is Tekla's got an option. If you go in here, it says odd end and last spacings. But if we do that, we're going to muck around with that. So what we'll do is we'll force a odd end and last spacing by putting in a space there and say 125 there, and click there and say space 125 there. And once we enter there, we get a perfect spacing. We've got 75 cover here. We've got 5 at 150. We've got an odd spacing of 125. Then we've got perfect 15 at 300. We've got an odd 125 again, similar to the other side, 5 at 150, and then this side we've got the perfect 75 millimeters again. So 100% set out ligages just like that by using exact spacings. And the result of this is it will go down nicely in your drawings. When you do your drawings, you don't have a decimal value as a spacing. So now that we've done that, let's flick back to our rendered version, and we can start concentrating on the main bars. Now, I want to show two options of entering the main bars here. The one is by using the longitudinal, and the other one is this longitudinal option, and the other one is by using the more point input. So I'll use the point input for the top, and I'll use longitudinal for the bottom, and let's see how that works out. Okay, so we'll click a longitudinal, and in our properties we can then go and say the engineer wanted a N24 as a main, and for the class we'll flick over to the traditional 4 for the main bars, and then for the offsets we'll clear that, totally clear that. And then for the spacing, the creation method, we're going to say the engineer needs a number, and the number of bars he needs there as main is 4. Let's say he wants 4 N24s down the bottom, and that pretty much sets the scene. So what we can do is if we hover over this section now, we can pick the bottom, and we can say, okay, now you could pick the top as well, but I want to show a different creation method on top. So we'll just stick with the bottom at the moment. So if I accept that, you can see that Tekla then puts the 4 bars perfectly in the bottom. Now, the issue here with that is, or the difference between the two is, I really want this bars to go the full span of the continuous beam so that I can use the splitter function to split these bars at the columns and get intelligent lapping, so I can manipulate them and offset them and rotate them. So what we need to do is if we click on these bars and we go to visibility and we enable our leg faces, we can see we've got our leg faces here. And now what we can do is we can click on this edge, hover over to our context menu, and make sure that we've got move in perpendicular direction selected. And then what we can do is we can basically just grab that edge, and you can see how Tekla holds it in that plane because we're forcing it in that plane. So it doesn't really matter where you snap to now. You know, you can really just pick a point or whatever, and it will keep it in that plane. It's not in a 3D plane. So that pretty much extends the bar across the whole lot. Now, this gives us the option to use a splitter and then do our detail at the bottom. So before we move on to that, the engineer is also asking for a additional 3 N24s in this main beam between those, and it's 4.5 meters long. So how do we do that? So again, I'll go over to the longitudinal, and in our bar, it's still an N24. Everything is good, but the distribution by number is now 3 and not 4. And then what we can do again is just hover over this section and say okay. So that will add extra 3 bars. Now if you look at this 3D image here, it's got these 3 bars on top of the others as a second layer. Now what I'm going to do is I'm going to click on those bars, and I'm just going to change the color so it's a bit more obvious what's going on there to 7 as the extra bars. And then what I'm going to do is I'm going to go Control P so we can see it from the top, so we can see what's going on here. Now the first thing, while we've still got our leg visibility active, the first thing we want to do is let's just tweak the and let me just select the bar. Let's just tweak the length. So the engineer is calling for a 4.5 meter bar. So if I select, just hover over the edge of this leg face here, we can see that the current length is 6.4 and it's got a bit of cover on the edges. So what we can do is click on that value, make sure that this middle or change from both sides is on, and then on the value we can type in 4.5 meters. That will shrink the bar exactly to 4.5 meters, and because this is now not on the edge of the concrete, it basically pulls the bar right up to the to this dimension rather than allowing for cover, because it's not associated with a concrete face. And then what we can also do is, while we've got that selected, at the moment it's in layer 3, it needs to go in layer 2 in the same plane as the other bars. And now that we forced that, let's go and see what's happened in 3D view. So if we go back into 3D view, we can now see we've got those two on top of each other. We've got this one perfectly in the center and that one on top. So to get the spacing of that perfectly, it's a very, very simple method. I can just do F on the keyboard to measure the distance, and I can hover from the center of that bar to the center of that bar and pop it there. That will give us 108 millimeters. We want to get to the center of this, which is 54, and then if I click on that bar we want to change, we can see there's already an offset of 63. So if we add 63 to half of that, which is 54, we end up with 117. So if I type in 117 there, Control A, 117 there, and I say enter, oops, and I changed the wrong one. Let me just undo that quickly. Click on this bar, beg your pardon, click on this bar, 63, we type 117, Control All 117, enter. We can now see that the purple bars, which is the extras, the 4.5 meter bars, is now exactly in the center with the other main bars, exactly what the engineer ordered. Okay, so that pretty much takes care of the bottom bars um, in terms of the requirement of reinforcement. We'll deal with the end modifiers and the splitters in a minute. The next thing I want to do is I just want to populate the top and the sidebars. So for that, I'm going to use the more function. Now the difference here is if I go more linear, I've still got 24s and these are going to be blue again. And what I'm going to do is on here, I'm going to say I'm going to clear the end and start and end offset. So Tekla can do an auto calculation. Distribution is 3. We can keep it to 3 bars in the top. So what we can do now, or we can just do it the same as the bottom and say 4 bars. So what we can do now that we have that, instead of showing a cut, we can say these bars basically span from here all the way to there. That is the shape of the arm, middle mouse button. And then for the guideline, we can just pick one side of the beam to the other side of the beam, and then Tekla pops that in for us straight away. Now, the big difference between this method and the method I use at the bottom, we didn't have to stretch the faces. Because we defined the beam, or the bar, the rebar shape, we could select the full length as a starter, so it gives us the same outcome. Now we'll use the same method since it's a better method or a quicker method. We will use the same, and this time I will specify a 20 bar N20 main, and I will pick a red color for our distribution. And for the offset at the top, that's the distance basically from here where the first one's going to start. I'm just going to pick a value. I want these bars to be 300 apart, so I'm just going to pick 250 from the top and bottom. And then what I'm going to do here is I'm going to say we're going to target, and the target's going to be 300. And let's see what happens when we do that. So if I pick again the full length of the bar to there, middle mouse, and I say that the guideline is basically from the middle here to the middle on top, we then get 3 bars spaced at 300 with the 250 grace of offset. So that works out to be quite a good solution. So if I go Control P to see it from the top, I can just zoom in here a little bit. I can pick the red bar, and then what I can do is going to right click, copy special, mirror, and then I can just mirror about the horizontal. Copy, clear, okay. And that basically gives us the top and the sidebars done. Now with that, we can pretty much see that all the reinforcements in the beam as the engineer required. What we need to do now is start finishing off the side. So I'll just do a redraw, and maybe this time what I'll do is I'll go into standard so we can see what the what the influence on the columns are going to be. So I'm going to start this side. I'll click on these bars and I'll switch off my leg visibility so we don't click them unnecessarily. So if I click on the bottom bars again, I can go to end. Now these and I'll just quit out of that for a minute so I can just explain. These bars at the moment, if I just switch on our leg visibility, our face ends here. So this bar is not aware of the column's end face. So if we want to extend this bar so it goes all the way across with a hook, but it ends in front of this ligature, we need to actually work out what that is. And I'll show you a very simple way to do that. And it's a very quick way. So if we click on the column, we can see it's a 600 column, so we know what the column's dimension is. Also, if we click on the column, we can see this column has got a 40 millimeter cover applied to it. And then if we look at the component, we can see that the ligatures in the component are R12s, and an R is a round bar, so the deformed size and the actual size is the same, it's 12. So how do we work this out? So if I just, let me just see if I can get my calculator up here. If I get my calculator and I say stay on top, what we can do is we can say, okay, let's start out. We need to extend 600. Now 600 will put us all the way to the edge on this side. Now remember, there's no face for this bar. This bar's face ends here. So if we extend this bar all the way to there with the hook's going to be smack bang in the middle of the face. And let me just illustrate what that looks like. So if I go say end modifier, make sure I load my defaults, and then it's a hook, and then I can say my alignment type is an end offset, and if I plug 600 in there and I hover over this edge here and I say extend, what I mean by it's in the middle, you can see that bar is sticking exactly in the center there. And the reason for that is because this bar's face ends at this point, it's not aware of a face there. So it's just going to do exactly what you tell it to do. So how do we fix that? So if I click on my calculator, I say I've already got a 600 extension. From that, I've got to take half the bar. Now that is a 24 bar, which means its deformed size is 29, and half of that is 14 and a half. So if I say minus 14.5, that gives me 585. That will put this bar flush with the outside of the column. Now, if we say minus the cover, we get 545, and then minus the ligature, which is 12. Minus 12 equals, if we plug in 533.5, that bar should sit exactly flush on the inside of that cover. Let's see if that works. So if I click on this modifier and I change the 600 to 533.5, enter, we can now see what's happened. This bar is sitting exactly 100% flush on the inside of that, as if it was determined automatically by rebar sets. So the reason I did that and went through this process is just for you guys to understand how cover is calculated and on what basis. When do we use the nominal diameter of the bar and when do we use the actual diameter of the bar, because this is crucial for working out covers and making sure that you can work. So you can actually determine all of these things precisely without having to just keep on changing this number until it looks right on the screen. It's dangerous to work. You can work that way. It's dangerous. You can work it out precisely if you know how. So what I'll do is I'll just get rid of that. So now that we know about that, we might as well also apply it to the top. Now on the top one, I'm just going to make a bit of a difference here. Let's say, for instance, the engineer decided that on the top one, we want a bit more length here, but also we want to increase the radius here. You can click on this end modifier, and then what you can say is, instead of having a standard 90 degree, we can say we've got a custom one, and instead of having a length of 220, we can say he now wants 350. And if we then say enter, you can see how this hook is much longer. And then also this radius, sometimes it will be necessary for this radius to be bigger, and then you can just change it out from 48 to 100 millimeters, depending on what the engineer wants. And once you've done that, you can see how nicely, we've dealt with that. So I'll click on this, and I'll also click on this bar. I'll hold in my shift key, click on that bar. Once I've got both of them, I can then hold in my, I can click, not holding in anything, I can just click on this modifier, hold in control, and then click on that modifier. And once I've got both of them, I can say control C, that will copy the two modifiers from this side all the way across to this side. And just like that, we've also dealt with the main bars on this end, and they're exactly the same as the other way. So as easy as that, we've dealt with that. Now all we need to do on this side is deal with these bars in a similar way. So what we can do with that is we can say we want an end modifier. I'm going to load the defaults for the end modifier. And this time I am going to extend them. And I'm going to extend them. They need to be a little bit shorter. So let's go 450 in this case. Let's just see where we get to. If I hover over the edge of this beam here, right there. I can see it extends, it extends pretty much exactly where we want. We don't want them to go too deep because we don't want any clashes there. So you could make it, I suppose, 500 just to butt up in the end there, but give the guys a bit of tolerance to work with. So we'll do it on this side. And then also what I'll do is I will click on this side, end modifier, and pick this edge and duplicate it on this side. Now, if we look at these bars in the middle here, we can see these two actually clash with each other. So how do we deal with that? So we'll click on the bar, click on the modifier, and under the hook rotation, we're going to say swing this hook by 3 degrees. I'll click on the other one, click on that modifier, and say swing this one with 3 degrees as well. And 3 degrees, as you can see, there is not quite enough. So maybe what we can do is we can say 5 degrees, just slightly pick on this one, click on this one and say 5 degrees. And that pretty much sort of twists them just enough so they don't touch. And now what we can do is we can copy these two modifiers, click on this bar, shift, click on that bar, then release, click on this modifier, hold on control, click on this modifier, and then control C. Click it from this end of the beam, we go all the way over to the other side, rotate it a bit, and then click on this end of the beam. And that changes that too. The only difference now is that we need, if we look at this bar, just click on that and say show only selected. This bar should be slightly twisted unless the mirror has fixed it up for us. You can see this bar is twisted. The one hook is pointing up, the other one's pointing down. So the way we fix that is we just come over to this side, click on the bar, click on the other bar, click on this modifier, control this modifier, so we've got the settings for both of them, and change the 5 to a -5 so they go down the same route. Now if we look at this bar, right click, inquire, we can see it's a perfect LL bar, and they don't clash with each other. That's probably what they'll do on site. Instead of trying to make this bar longer than that bar, try and avoid clashes, just turn them a bit, because that's what steel fixers do on site. To make bars fit, they just turn them and twist them a little bit. Okay, now that we've done that, we can start focusing on splitting these bars up. Now, I'm going to split up the red bars first because that's the easiest. So if I click on this bar, I can say give me a splitter, and then the split type, and I'll just load my standards to make sure everything is flushed. The split type is going to be a lap, and the offset. Now, let me just, before I do that, bring my sketch back up just to explain something here. Now, if we look at this sketch, we can see that this bar here is actually, it's got a bit of grace here. It's got a bit of working room here. So let's call it 100 mils, and then the lap. And up top here, we've got 100 mils and then an extended lap. So let's try and replicate that. So for the red bars, we work with a standard lap. So I'll click on the bar, go to the splitter. We've got a standard lap, and then for the split offset, I'm going to put in 100 millimeters. And then for the lap side, I'm going to assume Tekla is going to, the direction of this splitter is going to go from the bottom to the top. So I want the lap to be on the right. We might have to change it. I'm just guessing at the moment. So if we click on that edge there now, and I say accept, we can see that Tekla indeed, if you look at the arrow, it's pointing down. So you've got two choices there. You can click on the arrow. You can either change the lap then to be on the left, but it's easier just to come down the bottom here and say swap the ends. Now the arrow is pointing up and your lap is on the right, so it corresponds with your plane. Now once you've done that, you can just take this, apply another splitter on this edge of the beam, and again here we can see our arrow is pointing in the right direction. It's pointing up, but the lap is on the right, so all we have to do is flick this over to the left and say modify. And just like that, we now have a lap through a column for these bars, and we haven't touched our, influenced our end modifiers at all. Now that I've selected that, I can click on this and control click on this modifier, and I can say control C and copy them from this to this. And while we're at it, we might as well just copy it to this side as well, I think. Do this. Let me just see if that's actually copied correctly. No, I've actually moved it. So I'll just undo the last one. Or I'll just delete the last one. And I'll just do this side manually. So, well, it looks like I've managed to delete all. Well, let's just do them in manually. You can copy them, but I'm just seeing too many bars on the screen at the moment. Oh, I clicked the opposite side. It said you've got to be so good at making sure you select the right side. So now I know I'm on their side, my side. So let's just go to the splitter. So I'm going to be on the left. So let's try this side first. And that's worked out. Now I'll flick over to the right and click on this side. Hopefully it will still show it from top to bottom. And it doesn't. So just click on the modifier and change the direction and it fixes that up. So now those red bars are correct on both sides. And again, just go over to this side. You've got your splitter, pick your edge, and that's correct. And then pick the edge, and that's incorrect. So if I click on the splitter, I can just flick it over to the left, modify, and that fixes up that connection. And then obviously lastly, and these can be copied, but I'm just doing it manually now for the sake of the drill, and also for I'm just seeing too many bars at the moment. So yeah, again, you can see that the lap's on the right, the lap's right, but the direction is long. I like to keep my directions the same, so I can just down and then in here I can move it back to the right, then modify. So just like that, we've got the red bar sorted. So let's just have a look at them quickly. If I isolate them, show only selected, we can see what we've achieved. We've now achieved our hooks at the bottom, they don't clash, they're in the right direction. And also we've got splitters over the bar with some grace here to the columns minimum. So yeah, that looks pretty good. And also, if we just go into group mode here and we just click on these end bars and right click and we say inquire, we can see we still have an L bar. It's not distorted the shape at all. So we've pretty much achieved what we want to do. Okay, now that those bars are dealt with, let's deal with the bottom ones quickly. Now the bottom ones is going to have a splitter. So if I click on that, I'm going to say, give me a splitter, and I'm just going to load the standard. The splitting type is a lap. The offset is again 100. We do want a standard. And on this one, I think it's going to go left. Let's try. So if I hover over the bottom edge and split it, it's actually split it on the right. Why? If we look at the direction, we can see the arrow is facing towards us. So what we can do in this regard is just flick the arrow to the other side. So now the split's on the bottom. The other thing is also it's splitting now, putting the bars next to each other. We can then just flick that over and say, instead of parallel placement, we can say on top. Modify. Now it's putting it on top, but as you can see here, the wrong one is on top. But don't do anything about it now because we still need another splitter on this side. So what we can do now is if we go splitter and we click on this edge, it's on the wrong side. So if we click on that, we can just say flick over to the right hand side, modify, and just like that, it's now fixed it up. So what sometimes happens when you put in a split, you've got to split a bar twice. Don't go and try and change too many things, because sometimes it looks wrong. It flicks these bars. This one's at the bottom, this one's on the top. It looks wrong, but as soon as you put in your second one, it fixes it up. So sometimes do your splitting and then fix up when you know you've got all your splitting done. So with that in mind, what we can do now is click on this one, control, click on that one, and let's try our luck with control C again, and we'll copy it from this edge all the way to that edge, and that splits that bar successfully. And that pretty much completes the uh, the top, the bottom for us. Now all we're left with is the top. So if I click on this one, control, click on that one, go control C again, and then we can take this one to the top. That splits the top bars, and as you can see, it splits it perfectly, but we need to make an adjustment on these. So if I click on that bar, click on this splitter, control, click on that splitter to get both properties. You can see splitter 2 selected. We can then say that this lapping is not a standard lapping, it's a custom lapping, and for the length, the engineer is calling for, let's say, 1500 millimeters. And if I then extend that, we now see that we've got a much longer a lap at the top than at the bottom. We've got our standard laps in the middle. We've got our coverage here. Now, all we need to do to complete this exercise is to click on the bar, click on the top bar, click on this splitter, control, click on that splitter, and then control C to copy them. And we can copy them from this joint all the way across to this joint. And that's it. It's done. So that beam, let's just look at that connection a little bit, or I'll look at this one like so. So it marries the sketch. So if I do that and I bring our sketch along quickly, we can see that on the end here we have our lap. Well, we didn't put a lap, but the lap will be exactly the same. Now this beam is a little bit short for that. If we lap minimum, these two laps will touch. So this will have to act as a starter bar. You see, this beam is much longer. But we've got our long lap at the top, which is same as here. We've got our shorter lap at the bottom, but still a standard lap. And then for our distribution steel, which is not shown in this sketch, we've got the same lapping. And then for our stirrup spacing, we've got close over this joint, which is those. We've got our intermediate spacing, which is these here. And then we've got our short spacing, half spacings on this one again. So we've pretty much